Welcome everybody to a video about representing motion or kinematics with graphing. As you can see by this intro here, it will no doubt be super easy. So if you're interested, we're going to segue real quick into a review of graphing. So we have a lot of the related concepts to PT, VT, and AT graphs, dealing with the slope of each graph and what it represents, how to find displacement, how to find average velocity, when things can be curved or not curved. If you feel like this would be helpful, then I suggest pausing the video and checking it out. But what we're going to focus on today is drawing those graphs and what they mean. So what we're going to start with here is a PT graph with the curve as you can see here. Now you got to remember the slope of the graph represents velocity. So I'm focusing on the beginning and the ends of the curve. In the beginning, zero slope. At the end of the curve, I have positive slope. So simply that means that you start with zero velocity and you end with positive velocity. Draw those dots and connect the dots. From here, we know that this is constant positive slope. So that means that you will have constant positive acceleration. Pretty simple, I think anyway. But what it really means is that we're moving to the right here, whatever this object is, and that the velocity is increasing. The speed is increasing. We can tell because the velocity starts at zero and gets faster. So that's that form of a graph, and we have three more curves to go. The next curve looks like this. Again, we're going to focus on the beginning and the end of the curve. We start with zero slope and end with negative slope. Therefore, when you draw the VT graph, you should simply plot a point at zero and a negative point and connect the dots, and there you will have your appropriate VT graph. From here, we know this is negative slope, therefore we have constant negative acceleration. So what does this graph mean in terms of motion? Well, you should recognize that it starts from rest and increases speed while moving left. Left because it's below the x-axis in the VT graph. So it has a negative velocity. Again, negative just means left. The next graph we're going to do looks like this, where the curve starts with positive slope and ends with zero slope. So again, I'm focusing on the beginning and ends of the curves, and then I take that information, I translate it down. Draw a dot for positive velocity, draw a dot for zero velocity, connect those dots, and there's your VT graph with constant negative slope. Therefore, you have constant negative acceleration. What you should recognize, though, is that this means you're moving to the right and decreasing speed. Remember, you can't go less than zero. So maybe at this moment, you're like, why are we moving right? And this is you? Question mark? If that's the case, sorry for the lame effects there. Please remember, or please freeze this and remember that anything above the x-axis in a VT graph means positive velocity. Anything below means negative velocity. You're moving left. The farther you are from the x-axis, the faster the object is going. So back to these curves, we have one more left where it starts with negative slope and goes to zero slope. Again, focusing on the beginnings and ends of curves. You then drop those dots down in the VT graph going from negative to zero velocity. This has constant positive slope, therefore we have constant positive acceleration. In this graph, the object is moving to the left and slowing down. That's correct. Moving left and slowing down with positive acceleration. It is possible to slow down with positive acceleration. It just means that you're moving left and slowing down. So those are all the PT graphs. We're now going to move on to the 6 options for VT graphs. That starts here with starting with positive velocity and going to zero velocity, which means above that you should be drawing a curve that starts with positive slope and ends with 0 slope. Here I draw 2 quick tick marks to help me visualize. Don't forget, in class we used our hands to try and visualize, and you can see the shape of that curve. Then we go to our AT graph, which is the slope of the VT, and the slope of the VT is constant and negative. Therefore, I draw constant negative acceleration. This means that the object is moving to the right and slowing down. Now we could draw a very similar diagonal line, but start at a different location. We could start it at 0 and go to negative. So we need to draw a curve that starts with 0 slope and goes to negative slope. Again, trace it with your hand in the air if it makes you see it better, or draw little hash marks on your PT graph. Start with 0 slope, go to negative slope, and connect and make your curve. This is also constant negative slope in the VT graph, so you have constant negative acceleration. In this case, you're moving left and you're increasing speed because you're below the x-axis in the VT graph and you're getting farther from the x-axis. The final one we're going to do is the trickiest. It starts positive, goes to 0, and goes to negative, which means the slope of your PT graph must start positive, go to 0, and then go to negative. I've put hash marks here. I connect them as best I can. I'm not an artist, but that's the shape. We also have constant negative slope, so you have constant negative acceleration. This means that you're moving right and slowing down, then coming to a stop, and then moving left and speeding up. Please realize these are 3 different movements, all with negative acceleration. Negative acceleration just tells you how your velocity is changing. It doesn't tell you anything about which way it's moving. So we're going to do the same thing again, but we're going to draw these lines with positive slope. We'll start with a velocity that's negative and goes to 0. Therefore, you should draw a PT graph with a curve that starts negative and goes to 0. Again, trace it in the air if it makes you feel better and you can see it better, or use your hash marks. We have constant positive slope in the VT, so we have constant positive acceleration. In this case, we are moving left and decreasing speed. Yes. Remember, you can't go slower than 0, and we're below the x-axis in the VT graph, so we're going negative. The next one we can do is starting at 0 and going positive. Still a diagonal line with constant slope. So your graph should start with 0 slope and go to positive slope. Connect those 2 little line segments. This is constant positive slope on your VT graph, so we have constant positive acceleration, but in this case we are moving to the right and increasing speed. Above the x-axis and the VT graph is moving right, farther from it is speeding up. Now this is the tricky one. Start with negative, go to 0, go to positive. That means you have to have negative slope, go to 0 slope, and go to positive slope in your PT graph. As you can see here, I'm filling in those little line segments and I'm doing my best to connect, but I'm not an artist. So in this case, that means you're moving left and slowing down, you reach a stop, and then you're moving right and speeding up. Again, it's important to notice that all of these lines on the VT graph have constant positive slopes, so they have constant positive acceleration. And it describes 3 different kinds of motion. I know, it's crazy. You really got to focus on the x-axis and the y-axis of the VT graph and understand what it means. So that's it for this video. I hope you thought it was helpful in any way, shape, or form. If you ever want to come in and talk about it or ask for any help, you know where to find me. So thanks for watching. Hope it was helpful.